The first thing that we have to do here is to find the value of t when x equals to 2.5. So when x equals to 2.5, 2.5 means 2 to the 4, 4 plus 1 is 5 by 2. So when x equals to 5 by 2, all we have to do is put it here. So 5 by 2 equals to t plus 1 by t. So we can multiply both sides with t. It would be 5 by 2 into t equals to t square plus 1 by t into t is 1. Now we can multiply both sides with 2 to simplify the algebra. So 5t equals to 2t square plus 2. So we can have a quadratic equation 2t square. If I bring this 5t to this side, it would be minus 5t plus 2 equals to 0. I'm actually bringing this to this side and just reversing the order, that's all. Now middle term break. It's a quadratic equation, so we have to find two values of t. So 2 to the 4, and we can get 5 by 4 ones are 4. So 2t square minus 4t minus t plus 2 equals to 0. If I take 2t common, it would be t minus 2. If I take 1 common, it would be t minus 2 equals to 0. So this would be t minus 2, and this would be 2t minus 1 equals to 0. Therefore t equals to 2 or t equals to half. So we found two values of t. The next thing that we have to do, find the gradient of the curve at each of these points. So when you have this, so this is what's happening. So 2.5 is somewhere like this. This is the line. So 2.5, this is the line. Let me draw it properly. So 2.5, this is the line, and it's cutting the curve at this point and this point. So what we did here, when we put the value of x here, so we just found the values of t here and the values of t here, like a limit. Now the next thing we have to do, find the gradient of the curve at each of these points. So at this point we have to find the gradient, at this point we have to find the gradient. For gradient we need the expression, so dy by dt. So dy by dt is going to be t minus 1 means 1, and dx by dt, derivative of t is 1, and 1 by t means t to the power minus 1, that means minus t to the power minus 2. So 1 by 1 minus t square. So the expression, so dy by dt would be, dy by dx would be dy by dt divided by 1 minus 1 by t squared. So first at the point t equals to 2, so we have two values of t equals to 2 and t equals to half. So at t equals to 2 we have dy by dx 1 by 1 minus 1 by 2 squared. This would be 1 by 1 minus 1 by 4. So 1 by 1 minus 4 means 3 by 4. So this would be 4 by 3. At t equals to half, we get dy by dx equals to 1 by 1 minus 1 by t squared, means 1 by half squared. So 1 by 1 minus 1 by half squared means 1 by 1 by 4. So it means 1 by 1 minus 1 by 1 by 4 is a reciprocal, it will be 1 by 4, so this will be 1 by minus 3. So at t equals to half, the gradient is minus 1 by 3. Now that we have found the gradient at the 2 points, we have to find the area of the finite region. The area that we have to look for is this region. Find the area of the finite region enclosed between the curve and the line x equals to half. So this line is x equals to 2.5. So this is the region we are looking for. So for finding the region like this, what we have to do, we first have to find the area from this point to this point. So if we integrate from this point to this point, we can actually find the area, then we can multiply by 2. But we already know the limit from here to here. So since we know the limit of t, so we can just integrate the area in terms of t. So the Cartesian integration is going to be a little bit of a review. So the C2 rule says that if you have a rectangle, suppose this is the length and this is the breadth, the area is going to be L into B. Now this is a curve and it has a limit starting from here and ending here. It is made up of many rectangles. So the area of this region is given by integration of the limit starting at A, ending at B, and having a rectangle. The rectangle is length is y, so this vertical is y, and this breadth is dx. That means you add up all the rectangles. In other words, area is integration of limit a to b y dx. So this is the y and this is the dx. This is the idea behind the area. So getting back, so what we have to do here in question number C is we have to find the area. So the area would be given by the integration, the limit is Cartesian, x1 to x0, x1 to x2, y dx. So that's the area, but this is a parametric equations. For that particular reason, we have to convert this using substitution. So here we have to do integration by substitution. So integration by substitution means when we have a Cartesian integration a to b y dx, we have to convert that Cartesian into parametric by converting the limit t1 to t2, converting y in terms of t, and then converting dx as dt. So this is how we have to convert. So the idea is converting the Cartesian integration into the parametric integration. For this particular sum, we have already the values of t for the limit, so we don't have to worry about the limit. So we know, so for the limits, we know t equals to half and t equals to 2, so the limit will be from half to 2. And we also know, x equals to t minus 1 by t, so therefore dx by dt is 1 minus t to the power minus 2, that means 1 minus 1 by t square. Therefore dx equals to 1 minus 1 by t squared dt. So this is, we already know this. So when we do the substitution, if we can simply write, hence area equals to, so the limit x1 to x2 is going to be t equals to half to 2, y, we know the expression y is t minus 1, so t minus 1, and dx is equals to 1 minus 1 by t squared, 1 minus 1 by t squared dt. So this is, we have completely used substitution to convert this Cartesian integral into this parametric integral. Now we simplify, so half to 2, so if you multiply t into 1, it's t, minus, if you multiply t into 1 by t square, it is 1 by t, minus 1 into 1 is minus 1, minus 1 into minus this is plus 1 by t square, and we have dt. We can write half to 2, so this is t minus 1 by t minus 1, plus we can take this upstairs, t to the power minus 2. Now we can integrate. Integration of t is t squared by 2 minus integration of 1 by t. Reciprocal of a linear is logarithm, so ln t divided by chain rule, derivative of t is 1, minus integration of 1 is t, plus t to the power minus 2 is going to be t to the power minus 1 divided by minus 1. This is ax plus b to the power n. So, and the limit is half to 2. Now we try to simplify this. We can write t square by 2 minus ln t minus t minus 1 by t. So limit is half to 2. So let's put the value of 2 first. So this would be 2 square by 2 minus ln 2 minus 2 minus 1 by 2. Now we can put the limit of half. Half square by 2 minus ln half minus half minus 1 by half. So this would be 4 by 2 is 2 minus ln 2 minus 2 minus half. So this 2 and this 2 cancels, minus 1 by 4 divided by 2 is 1 by 8. No, 1 by 4 divided, yes, it's 1 by 8, minus, if I bring this 2 upstairs, it will be ln 2 to the power minus 2, ln 2 to the power minus 1. If I bring this upstairs, so minus 1 by 2 minus 1 by 1 by 2 is 2. So this would be minus ln 2 minus half minus, now this is 1 by 8. This, if I bring this minus in front, this would be plus ln 2, this would be minus, this would be minus 2. So if I remove the bracket, minus ln 2 minus half minus 1 by 8 minus ln 2 plus half plus 2. So minus ln 2 is minus 2 ln 2, minus half plus half cancels, so 2 minus 1 by 8 is going to be 15 by 8.